Welcome to this quantum security and defense presentation. Atomic scale innovation, enable quantum device fabrication for next-gen technologies. And thank you for being a valued member of our community. Maksym Plakhotnyuk is the CEO and founder of ATLANT 3D, a pioneering deep tech company at the forefront of innovation, developing the world's most advanced atomic scale manufacturing platform. Maksym is the inventor of the first ever atomic layer advanced manufacturing technology, enabling atomic precision development of materials, devices, and microsystems. A scientist with a PhD in nanotechnology and photovoltaics, he has deep expertise in nanotechnologies, renewable and exponential technologies, semiconductor processing, photovoltaics, solid-state physics, and material science. A Fulbright scholar, Hello Tomorrow Grand winner, and proud Ukrainian, Maksym has earned global recognition for his work. With 15+ years of experience and numerous patents, he leads ATLANT 3D's mission to redefine nanofabrication.
Good morning, good afternoon, or good night for all of you. Thank you, Anna and Steve, for organizing this webinar. It's my pleasure and honor to be part of this community and present what we do. My name is Maksym Plakhotnyuk. I'm a CEO and founder of ATLANT 3D. And this is a company based in Denmark. I like to say, create new materials and microchips out of thin air. So you would ask how it's related to quantum. So quantum is also now getting into microchips and require a lot of new materials. So I will touch this topic in more details over my presentation. So what we do, this is just one snapshot to demonstrate you what our value. You could see the glass wafer. On this one glass wafer, there are 5 different materials printed with multiple devices. As you could imagine, typically these devices would require shadow mask or lithography, about 5-6 cycles of lithography to make it. And probably 1 week of work in a clean room environment. All of this was done within only a few hours on one machine by switching from one material to another, including metal oxides in this particular case, but it can be sulfides, fluoride, or potentially nitrides. That's what we are developing today. So what I'll say, we enable a new era of advanced materials and basically also atomic scale manufacturing. So not only making new materials, but integrating them and making very complex devices. So about the company, we are 6 years old, based in Copenhagen, Denmark. We have office also in UK and US. We have expertise in atomic layer deposition. That's original our technology, and in applications, in devices, in systems. So we design machines and processes ourselves, and we focus on different markets, including MEMS sensors, catalysis, energy, battery, optics, photonics, and actually recently we developed one very interesting use case for quantum, and it's bringing us a lot of attention. That's the reason why I want to present what we do to your community, and thanks to Anna for setting up this opportunity to speak here. I think I forgot to present myself. What my background, I have a PhD in micro nanotechnology from a Danish Technical University. I also have a background in a little bit in material science and semiconductor processing. Originally Ukrainian, live now in Denmark for 11 years, and previously also live in US. And I started the company as one of the co-founders and running the company from the first day until today, and hopefully in the future. So about our timeline, so we started the company in 2019 from idea only, and with that idea we built the prototype, and when the prototype was ready, so we got interest from Sony, ST, Micro, from NASA, ESA as well, and we have been funded through venture funding, and we now moving also in a B round funding and start delivering our first product, which is Nanofabricator Lite. It's our desktop R&D tool, and we expect in this year to have also our industrial tool, Nanofabricator Pro, available actually in 1 month. And as you could see here, we also developed a special tool for zero gravity processing based on a NASA and ESA request, but that's a separate story. That's we look into making in space printing and electronic development. That's the paramount of our dreams. So what our vision and strategy? We build a very versatile and unique technology, and with this technology we develop different applications in different domains, and based on these applications we make a hardware platform which allows also even integrate metrology and integrate with industrial tools. Our goal is to set up customer hubs across the world, so making a hub network to create a rapid innovation in various fields, including in space. This is our facility in Copenhagen. So we have application, custom application and demonstration laboratory with 4 machines. As you could see here in the left bottom corner, we have a nozzle development lab. We have characterization, we have wet chemistry processing. It's not that big, but we are quite efficient in how we processing, and we don't require very sophisticated infrastructure to make quite complex devices. We provide also high throughput processing, advanced characterization, data analytics, and we collaborate with different partners across Europe. In Denmark, Sweden, Germany, but also we open to collaborate in other countries across Europe. So we basically, every stage in human civilization was dictated by the material progress. So you know about Bronze, Stone Age, Iron Age. We're now in Silicon Age, and I believe we are at the edge of kind of getting to the quantum material era, and that's what is very fascinating. This is what we all working on, and I'm really particularly looking how we can enable this with what we do. So with advanced materials, there are huge opportunities in different markets, and particularly with quantum materials, we can enable a lot of different new computational power, sensing, and not only. There is also the opportunity to accelerate such material development from material discoveries, including AI. But I will not talk about this topic. I will, if you're interested, I can address it, but I would skip for today. So let me just jump what we do. So what our technology does, in the closed loop of material development, we provide a very strong value in programmable atomic synthesis. That's how we call the process. And this programmable atomic synthesis, it provides digital recipes, multi-material flexibility, and also programmable deposition. And we're now integrating AI loops into this. So from design to discovery, it can be very fast comparably to traditional methods. And that's one of the key values that we bring with our technology. Just give me a second. Our technology works in the following way. So we design a micro nozzle, and this micro nozzle made of quartz. And in micro nozzle, we have channels. That's our core IP. And when the precursors are delivered through micro channels to the surface, as you could see, separated in space, they activate the surface. And with this approach, we can optimize, not optimize, we can activate locally chemical reactions. So basically, one motion or one pass along the specific spot, we deposit exactly one atomic layer of material, one monolayer of material. This is a technology that's based on ALD, atomic layer deposition. but made in a absolutely different manner. That's what our unique technological solution, basically.
You can join the CUSEC Dev community to watch the full version of this and over 80 other lectures on quantum technologies, attend events, receive free training, and more. CUSEC Dev is a users community working to forward quantum secure communications. The community is represented by Quantum Security and Defense that provides supply chain orchestration and consulting services on behalf of our members. Find out more. Google quantumsecuritydefense.com today.